Hello everyone, wishing all of you a very good morning. I hope, good morning Yashwant. I hope good morning Sainath. I hope all of you are safe, fine and healthy. And on that note, we begin today's class. Good morning Vahini. Good morning Santosh, Santosh. Okay, now before I begin my class, Jai Shri Krishna Yashwant. Before I begin my class, good morning Mansa, good morning everyone. Before I begin my class, let me start. Good morning Goli. Let me start with the same instructions. Keep your videos off. And if you have to ask anything, talk to me. Send your messages on the ID with the name Ask. Good morning Santosh. Okay. Now in today's class, we would be discussing graphs of single motion in one dimension. We'll be discussing graphs of motion in one dimension. Now, before going on into graphs, good morning, Sai. Let us go back and see what graphs were all about. Good morning, Deepak. What graphs were all about. Now, if we go in the very beginning of that thing, we had started with y as a function of x. Y is equal to fx. Go back to the class of basic maths, and we started with this y is equal to fx. F is a function. Y is a function of x. Now, if you remember or recollect, x here is known as, what is x known as? If you can, anyone tell me what is x known as? There are two types of variables that we had discussed way back, some 2 weeks or 3 weeks back in basic maths. What is x known as? Anyone can tell me what is x known as? Does anyone remember what is x known as? X is known as independent variable. X is known as independent variable, which is independent. But y is known as, what is y known as? X is known as the independent variable and y is known as the dependent variable. Do we recollect this? You can always go back on your app. Your app is very informative. Yes, Tija, very nice. You can see my lectures on basic maths where we have discussed functions, differentiation and integration, because we'll be needing it now. Y is the dependent variable and x is the independent variable. Now, whenever we have the independent variable, since we call it x, why we call it x? Because we always plot it along x-axis. The dependent variable, why we call it y? Because we always plot it along y-axis. So if you remember, we have seen the graph of x versus y. The independent variable is plotted on the x-axis and the dependent variable is plotted on the y-axis. Do we recollect this? Can I have some raise hand just so we understand this? We recollect this. This x is the independent variable. This y is the dependent variable. And this is how the graph is plotted. And we have name for this graph. Every graph has a name. Y-axis is always set first. So the name of this graph would be y-x graph. Do we recollect this? That sir, yes sir, this is known as the y-x graph. For example, if I plot here t and if I plot here v, now this t might be your time, this v might be your velocity. So time is the independent variable. Time does not depend on anything. It will just keep on moving in this forward journey. So time becomes your independent variable, which is plotted on the x-axis, and v, which may be velocity, becomes your dependent variable, which is plotted on the y-axis. What will be the name of this graph? What will this graph be known as? Yes, Chaturya. Even before asking my question, you gave me the answer. I'm very impressed. This graph will be known as VT graph. Velocity time graph, VT graph. Yes, Anjali, correct. Yes, Santosh, correct. VT graph. Remember, you always say y-axis dependent variable first, and then you call the independent variable. Some books may call it TV graph. They are doing it wrongly. Ignore them. VT graph. Now, this y as a function of x can have many types of things coming in. So y could be like this. It could be 3x plus 5. It could be as simple as this. 3x plus 5 is the function of x. Y could be a more complicated function. It could be a trigonometric function, something of this nature. Or it could be a trigonometric function and a combination of trigonometry and something else. Doesn't matter. Howsoever, whosoever, whatever be the function, we can always have a function of x which equates y. Here y is your independent, is your dependent variable, and x is your independent variable. Am I clear? Can I have some show of raised hands so that I understand that we are in the same universe? Only 6, only 8, only 10 people seem to have understood. So now is the time for calling out your names. No, the number is getting up. Okay, great. So we understand this. Now, as we all discussed in the previous classes, that the simplest form or the simplest graph that we have is this one. Y is equal to 3x plus 5. So this is a recap of what we have done in the previous classes. The simplest graph is y is equal to 3x plus 5. What type of graph is this? Which type of curve? What type of geometrical figure y is equal to 3x plus 5 will give us? What type of graph you will get? Yes, Santosh. Yes, Anna. Yes, Anjali. Great. We will give a straight line graph, which is the simplest form of a graph, is a straight line graph. Do we understand this? This is a straight line of graph. This is a straight line graph. In most of the cases, in most of the questions that you will y is equal to ms plus c, yes, we are coming to that, Kartik. In most of the cases that we are going to see, the questions will be coming with a straight line graph. So we'll be paying more attention onto this straight line graph. Now, once we got into this graph, y is a function of x, we also found out something which we called as slope of the graph. Something we also found out was the slope of the graph. So if y is equal to fx is a function of x, the slope of this graph was given by dy by dx, which is the derivative of y with respect to x, and we call it f dot x. Do we remember all these nomenclatures, all these symbols that we used way back in the class of basic maths? All these symbols, dy by dx, f dot x, then we have second derivative, d square y by dx square, then third derivative, and so on. We had found out many derivatives. So we had discussed graphs, we had discussed the functions, and we had discussed their derivatives as well. Now, this derivative is nothing but the slope of the graph. We also discussed this slope of the graph. Now, slope of a straight line graph, we had discussed. What about the slope of a straight line graph? Can anyone remind me? I am highlighting this. What about the slope of a straight line graph? What happens to the slope of a straight line graph? Why we call it a very simple graph? It remains same. Yes, Anjali. It is always same or constant. The slope of a straight line graph or a straight line is constant. Now, we also discuss what is this slope. We also discuss what is this slope. And we discussed that slope is the tail. Let me just cancel this out, VT graph, so that I can use this. So if I have a straight line like this, for those who don't remember it, what is slope actually? How is the slope calculated? So this is my x-axis. I've drawn the black line. This is my x-axis. Every straight line or every graph will make an angle with the x-axis. This angle theta with the x-axis, which is giving us this tilt. How much this straight line is tilted? What is the slope? How much it is tilted? Then we found out the tan of that angle. Tan is a trigonometric ratio, perpendicular divided by base. We found out the tan theta of this angle theta, and that gave me the slope of this straight line. Am I clear? Can I have some raised answer? We are clear with the slope of this straight line. And how did we find out the slope of this straight line? This is the perpendicular. Let me call this point as B. Let me call this point as C. Let me call this point as A. How did we get the value of this tan theta? This tan theta was basically equal to, remember your trigonometry, go back to your trigonometry. What was this tan theta equal to? Can anyone tell me? What was this tan theta equal to? Tan theta, I'm highlighting it. I've learned this new thing in this, highlight this. So what is this tan theta equal to? What is this tan theta? BC by AC. That is exactly correct. Perpendicular BC divided by base AC. Perpendicular BC divided by the base opposite divided by distance, whatever you call it, Goli, is the one and the same thing. Or you could call it like this. If I call the coordinates here, this coordinate can be called as y2, this coordinate can be called as y1. Yes, Teja, I'm coming to that. This coordinate is known as x1, this coordinate would be x2. So basically it becomes y2 minus y1 divided by x2 minus x1. Do we remember this? Y2 minus y1 divided by x2 minus x1. The vertical divided by the base, vertical divided by the base, yes. And then you may also remember that instead of calling y2 minus y1, which is change in the value of y, x2 minus x1, which is change in the value of x, we called it delta y by delta x. Do we remember delta y, change in the value of y, delta x, change in the value of x, change in the value of y divided by the change in value of x, and that was how we defined the slope of a straight line. Now I would ask all of you to lower your hands, and now only those students will raise their hands who have any doubt up till this point. This is just a recap of what we had done in the previous classes in basic maths. We had to do a recap and we have done it. Who has raised hands? Let me see. Yes, Satran, what is okay, you have lowered your hand, so that means it was raised wrongly. So I hope you understand what we had done till now. Okay, let me move ahead from this point. Now we also had seen different types of slope. We had seen positive slope graph. We had seen negative slope graph. The third type of graph is a zero slope graph. And the fourth type of graph was an infinite slope or an undefined slope graph. Now, can anyone tell me what do you mean by a positive slope graph? What is meant by a positive slope graph? Anyone would like to go back and tell me, sir, this is positive slope graph. What is a positive slope graph? Anyone? Increasing. What do you mean by increasing? Hannah, what is meant by increasing? What is meant by increasing? Hannah. Hannah means everyone. Graph in the first quadrant. What do you mean by graph in the first quadrant, Deepak? It's not clear to me what you meant by graph in the first quadrant. Yes, in first quadrant, tan theta is positive. I know that. Tan theta is also positive in the third quadrant. You have to understand it. If you don't understand it, you will not be able to solve questions on this. All silver teacups. That was all where all these ratios are positive or negative. I am talking about a positive slope graph. I'm talking about a positive slope graph. It has to lie in the first quadrant or the third quadrant. So let me put it here. It must lie in the first quadrant or it must lie in the third quadrant. Okay, but that does not make me understand. The graph would be like this. I have to understand it looking at this point. I have to understand it looking at this point. What is happening from here to here? That is how I will understand graphs and physics. I may not be able to understand whether they are lying in the first or the third quadrant. Please mark my words. You may not be able to understand in which quadrant they are lying. Increasing, Goli, what do you mean by increasing? You are missing something, Goli. Increase of x and y values, Deepak, not exactly correct, but I will manage. This graph means if x is increasing, x is the independent variable. If you increase the value of independent variable, if you increase the value of x, what happens to the value of y? Yes, this is how you understand the positive slope graph. If the value of x increases, the value of y also increases. Yes, that is how you understand it is a positive slope graph. Or you can call it in a different way. You can call the reverse of it, vice versa, reverse of it. What is the reverse of it? In first case, x was increasing. In second case, x would be decreasing. If x decreases, that will imply that y will also decrease. Such type of graphs will be known as a graph with positive slopes. You can also call it y is directly proportional to x. Y is directly proportional to x. If x increases, y increases. If x decreases, y decreases. Am I clear with this point? Can I have some show of strength? Let's say, yes, we understand this. We have recollected this. They are both directly proportional to each other. Directly proportional to each other. I only have 15 people out of 654. That's too less. Let me call out some names and let me wake you up and bring you to this wonderful universe. Hans, Yashwant, Vijay, Triveni, Tejasvi, Tarun, Shreya, Spidey, Sana, Shri, Reddy, Rahul, Padmakan, Naidu, Krishna, Karthik, Shashank, Kevin, Jayashankar, Jagdish, Jagdishwara, Satrika, Sai Teja, Santosh, Shatran, Bethany, Harsh, Arpit, Anil Kumar. Are you there always? Okay. Now I got around 30. Why you want me to call your names? Takes a lot of energy out of me. Okay. Anyways, that's my job. I'll do it. If x increases, y increases. If x decreases, y decreases. That is a positive slope graph. Now, what do you mean by a negative slope graph? What would be a negative slope graph look like? Now, if you can recollect, if you can apply some common sense, just Santosh, that is the common sense I was looking for. And the common sense is pretty clear. It lies in the second or the fourth quadrant, but that does not make much sense. When I look at the graph, I won't be able to find out whether it's in which quadrant. The easier way is when you increase the value of x, that will make the value of y to decrease. That will make the value of y to decrease. So inversely proportional graph. X increases, y decreases, or x decreases, implying y has an increase in the value. Y has an increase in the value. Well, that was the two types of positive and negative graph, positive and negative slope graph that we have discussed. Now, we may have discussed this, we may not have discussed this. What do you mean by a zero slope graph? A graph with a zero slope. Hanak says parallel to x or y axis. Hanak, you are partly correct and partly wrong. Karthik says constant. What do you mean by it? Karthik? You try to understand. I am a layman. I don't know anything. So you have to tell me things in a way that I can imagine them. You said you call it constant. I am at sea. I don't understand it. Make me understand in the simplest possible language. No changes. Not depend on x or y. No. You're still not clear. Everyone is still not clear. It is a graph which is x and y are constant. No, Karthik, confused. I got confused. It is a graph which is parallel to x-axis. It is a graph which is parallel to x-axis. No, Santosh, you are wrong. It is a graph which is parallel to x-axis. That means if you increase the value of x or decrease the value of x, y remains same or constant. Nothing happens to the value of y. Y remaining same, y remaining constant. Whatever happens with x, y is unaffected. Oh, I'm not worried about x. Whatever happens to x, I am least worried. That graph is known as a graph with zero slope. Let me plot it here. Let me plot it here. This is my x-axis. This is my y-axis. Independent variable x, dependent variable y. Now I have this revolutionary graph. This revolutionary graph is y is constant, y doesn't change, y doesn't change. The value of x, as you can see, beta, everyone, see here x ka value is x1, here x ka value is x2. When I'm moving from A to B, when I'm moving from A to B, the value of x is increasing. So when I'm moving towards right, the value of x is increasing. What is happening to the value of y? See, y ki value remains constant. And as you can see, this graph makes an angle of 0 degree with x-axis. There is no tilt, it is flat. In terms of road, if you talk, it is a flat road, horizontal road, flat road. Y is constant, slope is 0. Whatever you do with the value of x, value of y doesn't change. Such graph, which is parallel to x-axis, is known as a graph of zero slope. Am I clear with this point? Does anyone have any doubt on this? Okay. Then if you have understood this, you must be able to tell me what would be a graph with infinite slope or undefined slope. Yes, Teja, that was I was expecting from you. Great one. This would be a graph which would be parallel to y-axis. This would be a graph which would be parallel to y-axis. X remains same, x is same. The value of x does not change, but y changes. So we don't know why is y changing. We have no idea why y is changing. X is not changing, but y changes. Everything is happening in auto mode. X is remaining same, y is changing. Such graph, as you can see over here, beta, the value of x remaining constant, but the value of y is just changing. We don't know why it is changing. You are going from A to B, the value of y changes, but nothing happens to x. That is a graph of infinite slope. Such graph cannot exist because they have undefined. It's not good to call them infinite slope. They have undefined slopes. Such graphs are not possible. But still, theoretically, we can have such a graph where x does not change and y is changing. So do we recollect this? Different types of graphs, different types of slopes, positive slope, negative slope, zero slope, and infinite slopes. Can we move ahead? Why don't we call infinite slope as zero slope? I don't understand what your question better. Zero slope graph cannot be have infinite slope, it has zero slope. That is why we call it zero slope. Okay. Now, that takes us to the first type of graph that we are going to study. First type of graph that we are going to study in this. And the first type of graph will be known as position time graph. Have you heard about this graph, position time graph? Anyone knows about this position time graph? Anyone has heard about this position time graph? You might have heard about this graph in your 9th standard, position time graph. Sometimes you may also have a distance time graph. A distance time graph is very rare. Distance time graph is very rare. Distance time graph is very rare, but you might have some questions where instead of a position time graph, you are given a distance time graph. Now, first of all, we need to understand in this graph, we'll have different types of graphs. We'll discuss different types of graph. The first type of graph that we are going to discuss is a straight line parallel to x-axis. Your x-axis is basically your t-axis because t is the independent variable. So you will have a graph like this. Here you have plotted t, and here you have plotted position. Now, since this is a motion in a straight line, the body might be moving along x-axis. So you will plot x-axis here, the position on x-axis, or it might move along y-axis. So you can plot y here, or it can move along z-axis. So you can plot z, doesn't matter x, y, or z. We are just plotting the position in terms of an axis. Now, how does the graph look like? It's a graph which is parallel to x-axis. The graph just looks like this. At point, these are the 2 points, A to B. At point A, the time is t1. At point B, the time is t2, but the position remains same and the position is x. Now, what are the things that you can understand or note from this graph? Can anyone tell me? So we'll be discussing all the graphs on similar lines. So let us first try to understand what are the things that we can get from this graph. Number one, this graph is a straight line graph. This graph is a straight line graph. Yes, Anna, you are right. Number two, let us come to each and every point one by one. It's a straight line graph which is parallel to x-axis. What is the slope of this graph? Anyone, what is the slope of this graph? What is the slope of this graph? The slope of this graph is 0 and it is also constant, does not change. Slope is 0 and constant. Now, slope. Now, what does slope of position time graph give us? What will be the slope of position time graph give us? Slope of position time graph give us the derivative of position time, the derivative of position with time. What will it give us? It will give us the velocity of the particle. It will give us the velocity of the particle. The velocity is 0. It will give us the velocity of this particle. The velocity of this particle is 0. Do we understand this? Remember, velocity was vector-wise dr vector by dt. It was a derivative of position time. It was a derivative of position with respect to time. Do we remember this? If the slope is 0, the slope is 0. The velocity of this particle is 0. Am I clear? Only 3 people have understood this. What about the rest? The slope of position time graph, if you don't remember it, please note it down. Please notice now. The slope of position time graph, please note it now. The slope of position time graph will give us the velocity of the particle. The slope of position time graph will give us the velocity of the particle. Am I clear? Am I clear? Okay. Now, if the slope of position time graph gives us velocity, what will the slope of distance time graph give us? Slope of velocity time graph gives slope of position time graph gives us velocity. Yes, Anna. The slope of distance time graph will give us speed. Am I clear? Am I clear, everyone? Let me repeat what I'm saying. The slope of position time graph gives me velocity. The slope of distance time graph, time is missing here, will give me speed. Am I clear? Can I have a show of strength with some raised hands? Okay. Now remember, beta, Now remember, let me come here and discuss this point again. Let me write it here. Note. Let me write it as a note. Yes, beta, one thing I wanted to tell you. One thing I wanted to tell you was this. While I am taking the class, some of you may be able to take the notes. Some of you might not be able to take the notes. Doesn't matter, beta. While in the class, you just concentrate on the class. If you can take running notes, take your running notes. Else, I have this system in place. Zoom or no Zoom, connection or disconnection. I always have this file saved with me. It has got nothing to do with Zoom. This file is already on my laptop right now. So I'll be sharing this entire file with you just after the class. I'll be sharing this file with you just after the class. You can make your notes from that file, but you have to make notes, good handwriting. While in the class, you can make running notes in a rough copy. Running notes, I call it rough copy, whatever you've understood. And then I will send you this entire sheet in a PDF and make nice notes. So the lecture would be again coming back to you. And while you are making those lovely notes, you can have a look back at the lecture from your app. So you are looking at the lecture second time and then you are making your nice notes. Everything will get back into your head. This is what I would suggest to you. While in the live class, make running notes on a rough copy. You can make good notes while looking at the lecture. Afterwards, I'll be sending you this file as well. Division twice and you are done. Anyways, I was on the notes part. Note number one. Note number one. Slope of position time. Slope of position time graph gives us what? It gives us velocity. Remember, beta, remember, I'm very peculiar. I have written slope of position time graph. In most of your books, instead of getting position time graph, you will get something else. Those people, instead of drawing position time graph, would be drawing displacement time graph. Remember, beta, velocity is not the derivative of displacement with time. It's written wrongly in books. Velocity is the derivative of position vector with time. That is the real correct definition of velocity. So even if some book says displacement time graph, just ignore them. Understand that it is position and do it as position. So the slope of position time graph gives me displacement. Point number two, slope of, if you ever have a distance time graph, slope of distance time graph will give me speed. These are the 2 points that I wanted you to note. The second thing is, and note this thing very carefully, velocity is a vector. Velocity is a vector. So it has two things. It has magnitude and it has direction. Now, since we are in motion in one dimension, we are not using vectors for directions. Instead of using vectors for direction, what are we using? Instead of vectors for direction, if the body is moving like this, or if the body is moving like this, or if the body is moving like this, what are we using to understand how the body is moving up, down, left, right? How are we understanding it? We are understanding it by positive and negative sign. Yes, Sanak, signs. We are understanding them by signs. If something is moving along positive x, it is positive. Something along negative x is negative. Positive y is positive. Negative y is negative. So, since velocity is a vector, and we are taking positive and negative for the direction, positive and negative for the direction, when you have a position time graph, this velocity can be positive or it can be negative as well. So this slope of position time graph can be positive or negative. Am I clear? And I have some raised hand that we understand that, sir. Sir, position time graph ka slope. would be velocity. And since the velocity has direction and we are taking positive and negative for direction, it will always be positive or negative. It can be positive, it can be negative. Now tell me, what about distance time graph? The spelling is wrong. I missed C, I think. What about distance time graph? The distance time graph ka slope gives us speed. What can you say? Will it be positive? Will it be negative? These smaller points are going to make a lot of difference in eventual questions that you come. Positive, Hannah, yes. It is a scalar, it is a magnitude, it is always positive. So you can never have a graph. Never a graph is possible where the slope of distance time graph is negative. If someone draws a graph, distance time graph, and gives a slope as negative, you just tell me, okay, you don't know distance time graph the slope can not be negative. Yeah, it is speed, it cannot be negative. You have drawn it wrongly. Probably you have drawn a position time graph and you are calling it distance time graph. Wrong. Am I clear? We understand this. So these are the small points that you must understand. We call them names, we call them golden key points. They're known by different names. It's actually very simple. So that's what I wanted to make you note. Now let us come back to the graph. Let us come back to the graph. The graph is a straight line graph. The slope is 0, velocity is 0. Velocity is 0. As you can see, x coordinate, the position is same. Position remains same. Its position is not changed. Its position is not changed. What you can say about the particle motion? The particle must be at rest. Yes or no? Yes or no? Velocity is 0. The particle does not change its position. It must be at rest. 6 point. I'm putting everything, every question in one single graph. What about the acceleration of the particle? Does the particle have acceleration? Anyone tell me? Look at the graph. Use some common sense. This is all about common sense. No. So acceleration has to be 0. Am I clear with all the points? All the points about this graph, are they clear to everyone? Okay. So that was the first type of position time graph parallel to x-axis. And these are the 6 points that you must understand and mark when you come across such a graph. Let us go up onto the second type of graph here. Second type of position time graph. Here I have drawn it for you. This is T. I can plot X, the position in terms of X or Y or Z, doesn't matter. And this is the graph. It is a straight line graph tilted like this. Let us think about this graph and let us make the same points that we made in this graph. We had made 6 points. Let us make the 6 points here. What is the first point, anyone? What is the first point? This graph is definitely a straight line graph. Number 2, number 2, number 2, number 2. This is how we'll remember. Number 2, number 2. Slope is constant. Yes or no? Slope is constant. Okay, Anjali, that's correct. Number 3. The first graph had 0 slope. This does not have 0 slope, right? Now, if it does not have 0 slope, it must have, if it does not have 0 slope, it must have either positive slope or negative slope or infinite slope. What you can say about the slope of this graph? Do not say that it lies in the first quadrant. That does not make much sense. If it does not have 0 slope, it must have positive slope or negative slope or 0 slope. The descriptions are given. Tell me, anyone, what about the slope of this graph? It is constant. It is a straight line. What about the slope? Is it positive? Is it negative? Anyone? So I can just make here, just to make you understand, let me call this point as A. Let me call this a point as B. You are going from A to B. The time here is T1, the time here is T2. As you can see, when you are moving from A to B, time is increasing, and let us see the position X1. Yes, Anak, I think you are correct. You are absolutely correct. When you are going from A to B, look at this, time is increasing, the position is also increasing. Time is increasing, position is also increasing. So what about the slope of this graph? Slope is positive. Very correct. Slope is positive, Santosh. Not increasing, beta. Slope is constant. Slope is positive. Yes, Karthik, you are correct. Slope is positive. Slope is positive. Let us now come back. What about velocity? What about velocity? Slope is positive. So the velocity is also positive. Velocity is also positive. Yes. But slope is constant. So velocity is positive and constant. Yes or no? Tell me. Velocity is positive. It is also constant. Let us take to the point number 5. Is the particle at rest? No, the particle is definitely moving. Position is changing. Particle is definitely moving. Particle is in motion. Is in motion from A to B. I hope we can all understand this. What about the 6th point? Acceleration. Apply some common sense. Think what is acceleration? What is acceleration of this particle? What is acceleration of this particle? Velocity is positive and constant. What about the acceleration? Anyone? What about the acceleration of this particle? Anjali says constant. Anjali, you are wrong. Hanak says uniform. He is also wrong. Teja says positive. I don't understand what is mean by positive here. Acceleration is 0. Velocity is constant, beta. If velocity does not change, acceleration is what? Simple basic facts. Yes, Karthik, you are right. Yes, Deepak, you are also right. Acceleration is 0. Velocity does not change. No rate of change. Yes, Karthik, that's the right logic. Velocity does not change. Why will acceleration come? Acceleration only comes when velocity changes. If velocity does not change, acceleration has to be 0. No doubt, acceleration has to be 0. Am I clear? Am I clear with everyone? Can I have some raised hands? Show of strength from everyone that we have understood this, sir. Velocity is constant, slope is constant, so acceleration has to be 0. 20. Oh, great. Let me wake up who are sleeping. 2016, Surendranath, Triveni, Tejaswi, Tarun, Swati, Sri, Dogi, Parti, Sana, Sai, Padmakan, Naidu, Ramesh, Likita, Krishna, Yashwant, Karthik, Shashank, Kevin, Jagdish, Jagdishwara, Satvika, Hans, Charita, Srivasha, Manasa, Harsh. We all understand this, beta? Yes. So that is what we must understand. Looking at the graph, that is how things stand. What is the third type of graph that we are going to do? What is the third graph that we are going to do? Everyone can understand this now. This is my x. Oh, this is my t-axis. Let me plot y here instead of x. Doesn't matter, the particle might be moving along y. Now the graph is like this. A to B, particle is moving, I guess. Time here is t1, moving from A to B. Okay, one more question. Let me ask you one more question. Can the particle move from B to A? Can the particle move from B to A? Can a particle move from B to A? No. Why, Jam? Why no? Why particle can't move from B to A? It's very simple. Now I just put the arrow like this and the particle moves from B to A. Why can't the particle move from B to A? Why this red arrow is not possible? Why this red arrow is not possible? I can make an arrow. Making an arrow does not make any difference to the universe. It does make a difference to the universe. See, time cannot move backwards. Do you understand? I can't go back to the past. Yes, t cannot decrease, and so I can't draw a graph from B to A. I can only draw a graph from A to B. Am I clear? Small points make a big difference. Time cannot decrease. Time cannot decrease. Time only can increase. So this red thing does not have any significance. So let me cross this out. Let me erase it. Tongue, 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 tongue. Tongue, 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 tongue. Oops. Okay. Okay. So this red graph is not possible. Okay. Now let us discuss this graph. What is the first point about this graph? The green one we are talking, the red one is not possible. What is the first thing? This graph is a straight line graph. Number two, the slope is constant. As you can see, straight line graph, slope is constant. What about slope? Yes, Shreya, thanks. Slope is negative. Theta is not positive, it's negative. How do we understand it is negative? See, I'm going from A to B. Time is increasing. Time can only increase. It cannot decrease. But look at the value of y. Y is going down. Y is going down. T increases, y decreases. Yes. Inversely proportional thing. Slope is negative. Am I clear? Let us talk about the velocity of this particle. Velocity is constant and it is negative. Am I clear? The particle is definitely moving. Let me not write it. It's evident that the particle is moving. What about its acceleration? We come back to the point. We come back to the same point. I'm having all sorts of okay. What about acceleration of this particle? What about the acceleration of this particle? Yes, the acceleration has to be 0 because the velocity is constant. Am I clear? Show of raised hands that we understand this. So only 10 participants understood it. I'm a very bad teacher. That great. Good. Even before my asking, I got the response. Great one, good one. I'm very happy. Now let us move on from the straight line graph to something more enterprising. And what is that enterprising thing? Now I would be very pleased if anyone can tell me what is happening here. Let us look. Once you understand simpler things, the complicated things look simpler. Here is my time. Here is my x. Particle is moving along x. What did I draw? I draw this. This is definitely not a straight line. The particle is definitely moving from A to B. Time is t1. Time cannot decrease. We know that. t2. x1. And let me call this as x2. Let's discuss this. Let's hope we can discuss this correctly. What about the first point? Is it a straight line graph? Not a straight line. Not a straight line graph. So what about the slope? Is the slope constant? It's a curve. Is the slope constant? No. Slope is variable. Slope is variable. Why I'm changing the color of the pen? Slope is variable. Now, let us talk about whether the slope is positive or negative. Deepak has come up with an answer. Slope is positive. Why is the slope positive, Deepak? Same logic. Shreya. Give me the logic. Answer is not important, beta. If you understand the concept, answers will automatically come. Yes, xy increase. Don't call xy increase. You say when time increases, time is the independent variable. You call it correctly. Don't say x and y both are increasing. Don't call it. Don't say it that way. Say When time is increasing, x is also increasing, sir. Independent variable is increasing. Yes, you can call it x is proportional to t. Yes, Chatur, you can call it that way. T increases. Okay, Kartik, I understand this. See, beta, I'm very concerned of what you have understood. I'm not concerned with your answers. To help with your answers, the answers will come. The correct answers will come. Yes, that is correct, Deepak. The concept must be correct in your head. Time increasing, x increasing. That is positive slope. That is the positive slope. Okay, so slope is positive. Great, 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 great going. Great class today. Great class. Loved it. Slope is positive. Now let us talk about the velocity. Okay, okay. Before going on to velocity, slope is variable. That means the slope is changing. Now, when the slope is changing, it can either increase or it can decrease. Either the slope will increase or the slope will decrease. Now you have to understand, is the slope increasing or is the slope decreasing? Yes. So that is the next question. Slope is variable. Slope is positive but variable. We understand this. Is the slope increasing or is the slope decreasing? Siddharth Spidey, welcome back. See, I also got, just because you have come, so I put my Spidey thing as well. Slope is increasing. Teja, how you understand it? How, Deepak, do you understand this slope is increasing? How do you understand this? Slope is increasing. How do you understand this? See, this is not Kaun Banega Crorepati that you give me an answer and without any logic. There must be a logic. What's the logic? What's the logic? What's the logic? See here. See here. At point A, if I draw a tangent, at point A, the tangent has zero slope. The tangent goes like this. If I draw a tangent here at point this, the tangent will be like this. If I draw a tangent at point B, it will almost be parallel to y-axis. So if you look at the tangent cut tilt is increasing. The slope is getting more and more steep. If you don't understand tangent, the slope is getting more and more steep. More steep means the slope is increasing. Am I clear? The slope is getting, the curve is getting steeper. It is flatter at point A. Since it is going towards point B, it is getting steeper. And since it is getting steeper, I can write that the slope is increasing. Am I clear? Am I clear with this point? The slope is increasing. Can I have a show of strength with some raised hands? Yes, sir, we understand this, sir, that the slope is increasing. The curve is getting steeper, 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 steeper. Great. Great participation, guys. Great participation. Now, let us talk about, since we have talked about slope, let us now convert that slope into velocity. So let us talk about the velocity. Let us have the velocity points quicker in one sentence. Velocity is positive, variable, and it is also increasing. Yes or no? Velocity is positive, velocity is variable, and velocity is increasing. That takes us to the last point. The last point is, what about the acceleration? Now we may not be able to understand whether the acceleration is constant or acceleration is increasing or acceleration is decreasing. We can still call velocity is increasing. Velocity is increasing and velocity is positive. Velocity is positive and velocity is increasing. That means acceleration must be positive. Acceleration and velocity must be in the same direction, then only velocity can increase. Therefore, we can say that acceleration has to be positive. Am I clear? Are you getting my point, everyone? Is everyone getting my point? Velocity is positive and velocity is increasing. That means acceleration has to be positive. Am I clear? Can I have a raise hands? Okay. Now in the same graph, I am going to do something. In the same graph, I am going to draw another graph from A to B. And this is my second graph from A to B, the blue one. The blue one. Look at the graph blue one now. Look at the graph blue one now. And now I'll mark everything with blue. I'll write everything with blue. What is the first point about the blue graph that you understand? The first point about the blue graph that you understand. It is not a straight line graph. Yes or no? Says Santosh, it is not a straight line graph. Point number 2, what about the slope of this graph? Is it constant or is it variable? Point number 2, look at point number 2. Variable, yes, so this point is correct. The slope is variable. Slope is variable. Great. Great. Point number 3, come to point number 3, blue graph. What about the slope of this graph? What about the slope of this graph? Slope is positive. Yes, why is the slope positive? If the slope is positive, t increases, x also increase. T increases, x also increases. Slope is positive. Fourth point. Is the slope increasing or is the slope decreasing? Yes, Santosh, the slope is decreasing for the blue graph. It is becoming less and less steeper. Here it is very steep. Here it is very less steep. The slope has decreased. The slope has decreased. Am I clear? The slope has decreased. Point number 5. Velocity is positive. Velocity is variable, but velocity is decreasing. Yes or no? Yes or no? Velocity is decreasing. Santosh, yes. Point number 6, the most important point, Vahini. What about the acceleration? Velocity is positive, but it is decreasing. What you can say about acceleration? Vahini, wrong. Acceleration is not 0. Acceleration is negative. Yes, Spidey. I was expecting the same from you. Great one. Acceleration has to be negative because velocity is decreasing. Am I clear? Velocity is decreasing, velocity is positive and it is decreasing. So acceleration has to be in the opposite direction. Acceleration has to be negative. Am I clear? Can I have a show of raise hand? And so I will finish the class with the last of these graphs. The last of these graphs. And I'll discuss one of those graphs and I'll leave the rest to you. Point number 5, graph number 5. Here I have plotted x, here I have plotted t, and the graph looks like this. And the graph looks like this from A to B, quickly. This is time t1, this is time t2, this is position x1, this is position number x2. Now tell me the first point. What is the first point of this graph? What is the first point of this graph? Not a straight line graph. Yes or no? What about the slope of this graph, Santosh? Slope constant or variable? Slope is variable. What about the slope? Positive or negative? Look at this, yes, Shreya. Time is increasing, but the value of x is decreasing. So the slope is negative. Now slope is variable, so slope must be increasing or decreasing. Common sense, slope must be increasing or decreasing, common sense. Slope is decreasing, yes, correct, beta. Here it is very steep, but here it is very flat. So the slope is decreasing. Very nice, everyone. Slope is decreasing. Let us put everything in terms of velocity. So velocity is variable. It is decreasing and it is negative. Am I clear? Now apply some common sense and tell me about the acceleration. What about acceleration? Velocity is negative and it is decreasing. Yes, Jaya, you are correct. First answer in the entire class and you are correct. Velocity is negative, so it is going down, and the velocity is decreasing. So acceleration has to be opposite. Acceleration has to be opposite. So acceleration has to be positive. Am I clear? Velocity is negative and it is becoming less. How will it become less? When acceleration is opposite. When acceleration is opposite, that means acceleration must be upwards. Acceleration must be positive. Am I clear? Am I clear? Can I have some raised hands that we understand that, sir? Last one. I'll draw this last one. The last one is the blue graph. The last one is the blue graph. First point about this graph. What is the first point about this graph? This graph is definitely not a straight line graph. So first point is correct. Since this is not a straight line graph, the slope is variable. That is also correct. When time increases, t decrease. When time increases, x decreases. So the slope is negative. This point is also correct. Now come to the fourth point. What is the fourth point? Slope is decreasing. Is the slope decreasing here? Is the slope decreasing? No, Anna. The slope is increasing. Anna. The slope is increasing. Yes. Fifth point. Velocity is variable. It is increasing and it is negative. Velocity is variable. It is increasing and negative in the blue graph. The last point. Point number six. What about acceleration? Velocity is increasing and it is negative. So it is going down and it is increasing. It is going down and it is increasing. So acceleration has to be in the same direction. It has to be in the direction of velocity and it has to be negative. Am I clear? Am I clear with this point? What I would suggest is I would be sending you this file. You have a go through the lecture once again. And if you have any doubts, you can ask me in the next class. Meanwhile, what I would ask you is to go through your notes, which is coming right onto your screen. This is given in your notes. Position time graph, as you can see, position time graph. Everything that we have explained, I have explained in the class. I will be sending you this sheet. These notes are already with you. Have a look at the position time graph, the slope of the position time graph. Everything is explained in great details here. Then on the next page, what would you find is the different types of graphs that we have already discussed. The first graph where velocity is 0, the second graph where velocity is infinite, and the other cases. We have also discussed all the cases. So what I would suggest and request is that you go through all these graphs while you are at home, make your good notes, and then there are some problems given in your notes, starting from problem number 20, and I think there are 25 problems, 25. So from problem number 20 to problem number 25, please attempt those problems. I would be very happy if you can do this. You can also attempt problems from your DPP in the graph section. We'll come to that in the next class. Very good interaction with you guys today. I already have 400 messages. I would need more messages so that we can interact more. If you have any doubts, you can ask me now. Else from my end, I am finished with this class. I wish you all the very best. Happy Eid to everyone. I hope you enjoy the festival nicely, and we'll come back in the next class. Bye bye, beta.